The Weibull distribution function. The Weibull distribution function is used in reliability analysis such as calculating a device mean time to failure. The syntax is Weibull of x, comma alpha, comma beta, comma cumulative. The alpha is the size, the shape, while beta is the scale. So the values of alpha will be from 1, 3, 5 to 7, 9. So we use data validation. Data validation, list of names, and paste it. Now these are the values of alpha: 1, 3, 5, 7, 9. Likewise in beta, we also use data validation. We copy this and we assign this to the cell, data validation, list of items, paste, and you have these values of beta: 0.25, 0.33, 0.51, 2, 3, and 4. Now we can use the array formula to generate the dataset. Array formula, Weibull of the x values from 1 to 10, our value of alpha, our value of beta, and 0 because it's a probability density function. And we choose the value of alpha as 5, and we use zero point 0.3. So here's the trend line of this Weibull function. There's a small value there. We can use 2 and 0.25. No, we cannot use. Did I use 5 here? 5 and 0.3, 0.5 or 2. Next, we use the formula of the Weibull function, which is alpha over beta times x over beta to the power a alpha minus 1 times exponent of negative x2 over beta to the power alpha. So we start with the first one, alpha over beta. So array formula, alpha over beta, okay, times the next one, x over beta, x over beta, raised to the power alpha minus 1, alpha minus 1, times. So let's start first with this one. Let's let's see how it works. So we're good. Now we can complete with one more term, times exponent negative x over beta raised to the power alpha. So the values match exactly. So I can change that to 7, change this to 3. Now we can go to the area where we calculate the cumulative distribution function. So it is array formula of the Weibull of the x values. We have alpha and beta, and this time we use 1 because it's cumulative distribution function. So this one in yellow is the cumulative distribution function. Next, we use the exponential form. So again, array formula. Let's start with the exponential form. Exponent minus x over beta raised to the power alpha. So this one in green. Now I can factor in 1 minus. So 1 minus exponent. Now they're on the same line. So we can start with 3. And this is zero point 0.3. Gonna show up 0.5, 0.25, 0.5. There's a little bit in 0.5, then try 1. Now we're up in 1. Then there's 2. Our scale is 2. And our scale is 3. And our scale is 4. So we go to 5. We're gonna start with 0.25 less than 1 because nothing shows up. But if our scale is 1, something shows up. 2, then 3, and 4. And if we use 7, if we start at 0.25 or less than 1, nothing shows up, but we can start at 1, then 2, 3, and 4. And if our shape is 9, then start from 1, then 2, 3, 4. So this completes the use of array formula, data validation, and EXP or exponent function to generate the Weibull distribution function, both in the form of probability density function and cumulative distribution function.